So let's move on with the next talk. It's by Swati Jha. She'll be talking a bit about inside the decision why Groww chose NATS over WebStocks. She is as a front-end developer at Wayfair.
So first of all, I want to thank you all for joining in today. So today, we will see why Grow chose NATS over Gorilla WebSockets, and basically, this seems like a backend decision, right? But by the end of session, I promise you that you will know why it was very useful and how it impacted the overall performance, and how it impacted the front end, and how it basically improved the performance of live prices, and basically saved a lot of resources, and how basically we are using it at other places like order status update, and how it helped in cross platform updation. So like before starting, a little about me. So hello everyone, I am Swati Jha. I'm currently working as an SD2 front end at Wayfair. Here in Wayfair, I'm shaping the world of authentication and enrollment, and basically making the user journey easy. Prior to Wayfair, I was part of Five. There I worked on the server driven UIs, and prior to Five, I was part of Groww. There I spent almost 2 years, and I was the POC for mutual fund team. So if you have ever seen any mutual fund page after login, then in that case my work needs no introduction. You have already seen my work. So yeah, so that's it about me. So let's get started. So as Groww became the first leader, and basically first leader to achieve 10 million active clients along with 7.6 million active trader, scalability becomes the center of attraction or center of attention for each and every developer in investment port. However, like the basically the current infrastructure of Gorilla WebSockets and Kafka, so begin to show some critical limitation, especially in terms of scalability and real-time reliability. Because of these basically limitations of like Gorilla WebSockets and Kafka, basically it forced like Grow to explore other alternatives which were efficient and scalable. So ultimately, which led us to adopt NATS over Gorilla WebSockets and Kafka. So, let's understand these issues in depth. Like, what were those issues, and why basically those were causing a hindrance in our scalability, or why those were creating an issue for basically being a real-time reliable application. So the first problem was Kafka topic limitation. So in a stock trading platform where like users have like user follow a unique set of stocks. In Grow, we call it watch list. So in watch list, what user do is they basically like subscribe to their favorite stocks, and they monitor those stocks. Okay, so suppose in your watch list you want to add live prices of Zomato. So for that, Kafka will create a topic for this. Now you add more stocks in your watch list. For example, you want add the stocks of let's say Paytm, IOCL, and ONGC. Now Kafka will have to create separate topic for Paytm, IOCL, and ONGC. And as the number of user base in Grow grew, right? The Kafka have the limitation of Kafka to have limited topics became a concern, because like we are not using like the topics only in case of watch list. We are basically using topics to show it on the like explore page, or for the dashboard page of the user, where user can see all his investment. So this become a very big issue for the scalability. Second issue was like Gorilla WebSocket connection bottleneck. So basically, Gorilla WebSocket establish a persistent connection between client and server. enabling real-time live prices, right? But as the number of user in Grow grew, think of the scale, like there are millions of users, millions of active users maintaining the persistent connection between client and server. And as the Gorilla WebSocket have a very simplistic layer, maintaining the persistent connection became extremely resource intensive. The CPU usage and memory usage, because of the Gorilla WebSocket simplistic layer, was very high. So this was the problem with the with basically our like with scalability. Now the second problem was real time data delays. Okay, so Kafka have a retention policy, okay, which can lead to delay in processing real time events, and where data is changing in each and every fraction of second. This retention can cause a lot of issues. You know that the live prices of each and every stock can change in each and every fraction of second, and if there is a delay in stock live prices, this can lead to a missed opportunity for the user. And Grow being a customer obsessed company, it was a huge deal in itself. Second thing which could have led to real-time data delays was reconnect and data loss with the Gorilla WebSocket. So suppose if a trader lost connection in between, or like his connection was dropped momentarily, the system had no built-in mechanism to reconnect smoothly and recover the most recent data. So with and there were high chances that user might see scale data or old data, right? But this was so not acceptable. So for this issue only, because of the reconnect and data loss issue with Gorilla WebSocket, we had to do extra handling on the front end and back end side to avoid these such scenarios, to avoid these kind of scenarios. Then the third problem was the complex user specific data handling. As I mentioned before, right, that Grow have watch list, right, where user can add their favorite stocks and can monitor them. uh, or basically user have a portfolio, right, where basically they can see all the stocks in which they have invested. There as well, basically there is live prices, okay, so that they can see how live prices are fluctuating in the stocks where in which they have invested. So this is kind of a user specific feed, right? Because each user want to see the updates that are relevant only to their own portfolio. So now for Kafka, for this kind of behavior, Kafka require complex mechanism before and is very hard to manage. So basically, to deliver personalized stock updates, Kafka required complex mechanism to handle user specified topic. Other reason for complex user handling was Gorilla WebSocket simplistic layer. As I mentioned earlier as well, in the scalability issue, that user specific handling with Gorilla's WebSocket was basically very hard, because Gorilla WebSocket did not natively support the kind of fine-grained user-specific communication required by a stock trading platform. It did not had any advanced feature needed to efficiently route stock updates to individual users without adding any additional layer of logic. So these kind of combined limitation of basically Gorilla, WebSockets, and Kafka led to significant problem in scaling and in case of real-time reliability. And basically, as the number of user base started growing back in 2021, scalability was one of the main concern of Grow. And also in by the end of 2023, Grow touched 10 million active users. So scalability and real-time reliability was the main thing which if each and every engineer in Grow was focusing. So to avoid all the issues with Kafka and Gorilla WebSockets, basically we explored more reliable option and basically more scalable option, which was NATS WebSocket. It's not like with these limitation, user was being impacted, but there was issue with scale because there was a lot of extra handling which we needed to do to overcome all these issues. For example, the issue of user specific user specific handling needed an extra handling from the in the Kafka and WebSockets. So to avoid these issues, we adopted NATS in the mid of 2023, and NATS had a lot of things which like a lot of features which helped us to overcome all our issues. So remember, like the scalability issue which we talked in the starting, the first issue, remember? So about like in that we discussed, right, that Kafka have limited number of topics, and in case of Gorilla WebSocket, persistent connection issue for handling millions of different stream because of the web is very difficult, and basically because WebSocket layer is dumb, right? So this problem, this basically scalability issue, which was the major concern of Groww, this was solved by NATS because NATS introduced subjects. Subjects are basically lightweight and are dynamic in nature. So now, suppose unlike Kafka, where we had to basically subscribe or to basically we had number limited number of topics, NATS can create multiple or millions of subjects and can manage them easily without impacting performance. So now traders can subscribe to personalized subject such as such like personalized subjects such as stocks Zomato, stocks Wipro, stocks Tata Steel, like for stocks Zomato we are subscribing to Zomato stock. For stock with stocks Wipro we are subscribing to Wipro stock. With stocks Tata Steel we are subscribing to Tata Steel stocks. And now traders can subscribe to personalized stocks without any like problem and without any extra handling from the back end side, right? Which was very crucial because think about the scale, millions of traders are subscribing to different stock updates each and a single day. And so this helped us this like the subjects in NATS helped us to solve the scalability issue of our basically of life prices. Now the second problem, remember, the second problem was retention issue, correct? Which led to the like which could have led to the delay in processing real time events, or which could have led to like which might cause the issue of like uh, delayed live prices, right? But now as NATS work on fire and forget system where messages are not retained, which is ideal for our use case because we are using it for live prices, not for a messaging system where we have to basically get the old data as well. We need the fresh data. So it is the best for our use case that it operates on a fire and forget system and ensures that every client gets the most current data without any delay. And so always latest data. Also remember the Gorilla WebSocket that the reconnection was not smooth, right? As the reconnection process is not smooth, the user might see the scale data, right? Remember that issue? That was also solved by NATS because now the NATS offers a very robust handling of connection loss. If a trader loses the NATS WebSocket connection, NAT automatically reconnects and begins streaming the latest data. No retention is like in our case, no retention was beneficial, right? Because we don't need the like scale data or all data. We need the fresh live price update. So now uh, even if a trader connection is dropped or basically for a few seconds or basically there is a connection loss for few seconds. Even in that case, nets will automatically reconnect them, and they will start receiving the fresh live prices update immediately without having to refresh the page. And this was in itself was a big deal, because this helped us to guarantee that users are seeing the fresh data. Users are not seeing the basically the scale data. Low latency and real time delivery. The nats are built in such a way like that the that it is automatically optimized for low latency communication, which automatically means low latency and real time delivery. So now messages are pushed to subscribe with near zero delay, ensuring user receive real time stock update. So this was the issue with the this was the things which helped us to solve the issue of real time update and made it reliable for real time live prices. Now, the third problem with Kafka and Gorilla WebSocket was complex user specific handling. Remember that? Now, in this case as well, NATS stand out because NATS follow pub-sub model for personalized data. Means publisher publisher can send messages to a subject without needing to know which subscriber are listening to that subject. Okay, so like we have a pub sub model, right, in which one publisher publish and subscriber subscribes, right? Now in this case publisher can message to a subject, okay, without needing to know a subscriber are listening to that subject or not. And similarly subscriber can listen to any subject without needing to know publisher, that who is publisher here. This decoupling allowed high scalability and independence between system component. Now, each user can subscribe to relevant stock updates through unique subjects, does not need any extra mechanism to manage these subscriptions. So now user A here, like suppose I am a user A and I can subscribe to stocks.zomato and stocks.wipro, okay, and user B can subscribe to subjects stocks.infosys and receive update for infosys stocks without being flooded with unrelated data, right? So this all these things does not need any sort of extra handling because of the pub-sub model and unique subjects. So now each user can subscribe to relevant stock updates through unique subjects, and the system does not need any extra mechanism to manage these subscriptions. Okay, so by unique subjects, I mean that like for Zomato stocks, I will basically use create a subject which is unique in itself, and for user specific personalized note, I can create a subject which is basically unique for the user. So message sent to the subject will be consumed to a specific user only who are interested, right? So these were few things which basically helped us to maintain a scalable system. And this was the benefit of using a pub sub model for live prices, which helped us to basically create a scalable and real time reliable application with making it making the Groww best application for where speed application for stock trading application, because in a stock trading world speed and accuracy is one of the most important thing, right? So adopting nats helped to scale as well as to basically manage speed and accuracy. So yeah, that's all the this is all the benefits which was provided by nats for in the live prices. So let's take take a summary, like what does in which things nats help, like, and why. Nats are scalable and flexible because of the subjects. Second thing is nats doesn't have retentions. Because of that, it ensures that we have instant delivery. Third thing is that basically we have real time user specific subscription, which means that without any need of any extra mechanism, we can get the basically real time data, user specific real time data. And fourth thing was that resilient connection handling, which means that user can like get the real time data, or even if the connection was dropped, or even if there is a drop uh, in their connection. The fifth thing is like low latency. The latency is very less in case of nats, because it provides the real time stock updates with virtually no delays. And the cross sync platform syncing is very high as well. I will tell you, like, in other application of nats, that how cross platform synchronization is also maintained with the help of nats. So when we implemented in the mid of like in May, we implemented or launched NATS for all the users in Grow. We checked the metrics, and the result came out to be awesome. Like, first thing was the architecture. Because we don't need the extra load balancing, we don't need the extra like mechanism for user specific behavior. So this helped us to lead a simplified architecture on the backend side. Second thing was like it helped us to optimize the resource by 2.5x times. Like earlier, the amount of resource which was used by suppose 1 million user, the same amount of use resources now we can be utilized by 2.5 million user. So you can see the scale, right? So the resource optimization was one of the biggest win for Grow. So this was the outcome of uh, implementation of NATS WebSocket in live prices, which was simplified architecture, optimized resource, and great performance. Now, uh, this is the part in which we have implemented live prices. Like we have implemented NATS and live prices. There were few other places as well in which we had implemented NATS. So the few other examples where we have implemented NATS was its HNS system. Okay, so HNS system, like unlike live prices, right? In live prices, we use pub sub pattern. In case of HNS, we built request and reply pattern. Okay, and created a real time messaging system. Before the NAT using NATs, like Crow was using a third party library. So the request reply pattern helped. Uh, the request reply pattern of NATs helped Grow to build a robust HNS platform, which can be highly responsive and scalable application. Other use case was its order status use case. Before nats, what we were doing in front end was we were we were doing the polling to get the order status. Suppose the user have placed the order. Now we are waiting for the order status, that it is in pending state, or the order status was successful, or it is in the it failed. So for that we were doing polling, okay, which increase the load on the server, right? So this was solved as well do when we did the when we implemented nats in case of order status as well. And as we made it real time order status updation real time, it helped in the cross platform synergy as well. Because now we can see the order status update consistently both in web and mobile at the same point of time. So yeah, so this is all the places where we have implemented nats. And this was where basically why like now I think you know why we have implemented NATS over like Kafka and Gorilla WebSockets. So that's it about my time. So like if you have any questions, you can reach out to me on Twitter or on LinkedIn. So that's it about me. Thank you so much, guys.